So if we go to level 0 here, this is the introduction, hello Ethernaut. We can open up our DevTools console. And this is really how we're going to be playing here. Make sure we have MetaMask set up. Need a MetaMask wallet. Get some testnet ETH. Ethernaut has some built-in stuff that we can play around with. This here, player, this reflects my MetaMask wallet address. And there's a few other commands like get balance and things. See how this responds with the promise since we're in Chrome. To avoid that, we're going to go ahead and put await before it, and then that'll just give us our clear answer here. So that's just good to know for later. And then Ethernaut, the Ethernaut command, this is actually a contract that we're going to be interacting with. If we do ethernaut.abi and then expand this, this kind of gives us all of our methods and things that this contract can do, different functions and things that are built in. For each level, we have to get a level instance. So we click this button down here. A transaction will pop up that you need to sign. Just hit confirm on that MetaMask transaction. It's going to mine out the transaction. Here we go. And it's given us an instance address here. Now that we have this instance up, we can use contract to access it. So let's do contract ABI, and this is going to give us some of these methods here. So this told us here, use contract.info first, and this will lead us through. So let's go ahead and do that. So await contract.info. Make sure you do the parentheses. So it calls it. Okay, find what we need in info1. So let's change that to info1. Try info2, but with hello as the parameter. Quotes around it. The property InfoNum holds the number of the next info method. Go ahead and do InfoNum. 42. All right, info42. The method name is the name of the next method. So await contract dot the method name. The method name is method 712. So let's do same thing. Await contract dot. All right. If you know the password, submit it to authenticate. All right. So if we know the password, submit it to authenticate. If we go back up and look in our contracts ABI here, there was this password method here. So let's go ahead and try that. Await contract dot password. Okay, Ethernaut 0. And it said, once we know it, we need to submit it to authenticate. So let's copy this, or we could just type it. So await contract dot authenticate. And we need to use Ethernaut 0. Quotes, I believe. Sign the transaction and wait for it to get mined out. And once it's mined out, we should be able to submit our instance right over here, and we will have credit for it and move on to the next level. And this is just the tutorial level to kind of get us acquainted with it, so we kind of understand how we're interacting here in the console and kind of how the instances and contracts work. And that contract.abi definitely will come in handy to give us more information that's not readily available right away. Okay, so this was successful. Go ahead and submit here. When you submit, you also have to sign a transaction. And when it gets sent back, then it should have a little congratulations message, and we can move right on. And I will just cut there we go. I will cut the mining part out of the rest of the video, but all right, go to the next level. So level 1 is called Fallback. It says, look carefully at the contract's code below. You'll beat this level if we claim ownership and reduce its balance to 0. Looking over this, let's go ahead and get our instance. There's a few functions here. There's a contribute function. There's a get contribution where you can check your contributions. There is a withdraw that is set to only owner. So this is how we will withdraw the balance to 0 once we have claimed ownership. But let's figure out how we can claim ownership. Okay, we've received an instance address. Let's start with our ABI maybe. and kind of give us an idea. Okay, so non-payable, yep, these are all these that we saw here. Let's go ahead and call owner. Okay, so the owner is not us because my address starts with OX7. Yep, 797. So this last function, this receive function here is of interest to us. And if we look at the Solidity docs, this receive ether function, it can have at most one. So it's executed on a call to the contract with empty call data. So no data attached. Just send a transaction with ether. It's executed on plain ether transfers via send or transfer. No such function. Okay, so this is what the tips were telling us about right up here, fallback methods and sending it outside of the ABI. So let's go ahead and take a deeper look at this because we're going to need to use this receive to claim ownership. We can see there's two requirements here. It's got require message value greater than 0. Okay, so we need to send some sort of value with it. And our number of contributions needs to be greater than 0. And it will send here. So our number of contributions must be greater than 0. Let's see here. We should do, if we use contribute with a small amount of ether, then our contributions should be increased greater than 0. And then we should be able to call receive. All right, so we know the message value must be under this amount of ether, 0.001. In the help here, we can convert this ether units to way with the two-way command. Under this amount, let's go ahead and just make it 2 extra zeros and a 9. And this is going to give us our way amount. Copy this, and we are going to make our first call to contribute here. So what we're going to do is await contract dot contribute, and the way to use to add our value in here, we're going to do curly brackets here, value colon, and then our value. And when we go ahead and send that, a transaction should pop up for us to sign, confirm in your MetaMask. And once this is sent, our contribution should be greater than 0 because of right here. All right, it's confirmed. Okay, so now that we have sent a transaction with the contribute function, we are going to just go ahead and contract.send like we saw in the Solidity docs. And we're going to do that same curly bracket with our value. Oh, I apologize. We need send transaction. So it's going to be send transaction here. There we go. And now this should pop up a confirmation, confirm it. And then while this is being mined out, once it confirms, it should have changed the owner to us, the message sender here. So this value greater than 0 and contributions greater than 0 should have made us the owner. And we'll check that with await contract.owner. And that's me, 797. And it wants us to drain the balance. So since we are now the owner, we should be able to access the withdraw. But I would like to open up this Etherscan link here and take a look at this contract. Okay, so this is the contract that we have been interacting with. Here's our first contribute from my address. And then there's the transfer that we just did with send transaction. And then it's got this much balance. So we should be able to use withdraw to receive that much balance back. So let's go ahead and do that. Await contract.withdraw, confirm the transaction. Wait for it to confirm. And then we'll check back on Etherscan that we have drained that balance to 0. Open this up here. And now this is that same contract here that had this, is now at 0. And we should be able to submit, confirm or submit in MetaMask. And I know that MetaMask is not popping up on the screen, but it's just a sign of a transaction. Just press the confirm button. There we go. Next level is called FAL1OUT. FAL1OUT in this picture here, FAL1OUT. So claim ownership of the contract below to complete this level. Things that might help: Solidity Remix, IDE. If we take a look over this code here, there's a few functions that all seem somewhat normal. Collect allocations, send allocations. All these things, only the owner can collect, okay. Okay, for some reason, this constructor comment, it comes right above a function, FAL1OUT, spelled with that incorrect thing in there. So let's see here. Let's get our instance and see if we can interact with this function here, because the constructor normally, let's see, constructor solidity docs. Yeah, when a contract is created, let's see, where did it go? When a contract is created, its constructor, a function declared with the constructor keyword, is executed once. Constructor is optional, only one is allowed. I didn't see. Normally the constructor is above these any functions up here. So yeah, I think this is our mistake here that we need to take advantage of. I don't think that is supposed to be available to us. So let's go ahead and check our contracts ABI. Okay, so let's go ahead with this FAL1OUT here, and let's see what it does. It makes us the owner, and it changes our allocations to message value. Okay, so we're trying to claim ownership. Let's go ahead and await contract dot FAL1OUT with the 1. Sorry, my dog was going crazy. All right, so let's call this, and it's going to set the allocations to our message value. So let's just put a really small amount away, like 1,000. Let's send it off. Oh, nope, we don't need one. All right, so we've sent this FAL1OUT transaction. Let's see what it comes back as once it is mined out. Okay, so let's see, await contract dot owner. And we're the owner. So the problem here was this constructor was actually a function rather than a constructor, using the constructor keyword. And these are supposed to only run once at the beginning when the contract is deployed to the blockchain. But anyone can call it since it's public. Anyone can call it, and it instantly changes the owner over to whoever called it. So that is a big problem. So let's go ahead and submit our instance and confirm it has worked. There we go. Congratulations.